now using the fundamental theorem of calculus, that's what FTC stands for, to find the either area under the curve or the difference in the area of the curve. So again, we're going to graph it and kind of show what the area represents, all right, or the difference in area represents. So we've, and now it says case 1, but it should really just say case 1 and case 2. I do both cases. All right, so the first example, and again, show your work correct. And again, the notation's important. It's kind of like the limit. Notation has important meaning, so when you're doing this on the quiz and the exam, make sure you show the same notation that I do, because it's important. It's kind of like writing the same, you know, if you're in a Spanish class and you have the right punctuation and stuff, that's what you want to do here, because it all is important. Alright, so we want our function y, which is 4 minus x squared over negative 2 to 2. So we want to find the definite interval. So what we want to solve is we want to integrate from the low value is negative 2, the high value is positive 4 minus x squared. Alright, so I'm going to integrate first, and then I'm going to graph it and look at its how it relates to area. Is it the area under the curve, or is it a difference in the area under the curve? Alright, so first, the first thing you do is you find the general antiderivative. That's the first thing you do. So the general antiderivative would be 4x minus x cubed divided by 3, and then we only took care of the integral part, right? The integration part. I haven't taken care of the negative 2 and the positive 2, so to indicate that I haven't done that yet, at the end of this, we do negative 2 to 2 to tell the reader that I still have to take care of those, and then we do that in the next step. I'm going to take my antiderivative, plug 2 in, and take my antiderivative, plug negative 2 in, and then subtract the difference. And again, you should show the values. I want to see the values. And so when you plug 2 into this expression, it's going to come out, it doesn't come out particularly pretty. It's 5 1/3. So again, I'll leave the fraction. Right, 5.3333, which comes out, which is 16/3. Alright. And then the negative would be 4 times -2. Comes out negative 16/3. Alright, so remember it's minus the negative, so it's 16/3 plus 16/3, which is 10 2/3 or 32 1/3. Alright, that's what the definite interval, that's what this definite interval equals. Alright, and so that's the work we want to see. So when we want to see this, we want to see this, the steps and the setup. Right, now the graph of that, so to see how that translates to the graph. Alright, so the picture would be, so I graph my function, and you can graph it on your calculator. Again, this is a parabola that's opening down. It's not that hard to graph. It's the x squared reflected and shifted up 4 units. So 1, 2, 3, 4. Crosses at -2, crosses at +2, opens down. Alright, so since I'm integrating from -2 to 2, this is the region we found. Alright, well, so in this case it does equal area. The area, since f of x is greater than 0 from negative to greater than equal to 0 from -2 to 2. The area is equal to the integration. And so that does equal 32 1/3. So that's this exact area is 32 1/3. Right, the second example I believe is going to be a difference in area. Alright, so I've got my function 4 minus e to the 2x from 0 to 4. So again, I want to integrate from 0 to 4. 4 minus e to the 2x with respect to x. So again, the first thing I'm going to do is solve the definite integral using the fundamental theorem of calculus. So the first thing you do is you find the general antiderivative. So 4x minus e to the 2x. But remember, divide by 2. It's really easy to forget that. Again, I myself, on occasion, would forget that. Not done though, you're right, that's just the integral part. I haven't taken care of the lower value or the upper value yet, so again, you have to indicate that to the reader. I've found the antiderivative, so I've taken care of the integration part, so the integration symbol drops out, but I haven't taken care of the upper value and the lower value yet, right, which I do that in my next step. F of 4 minus f of 0, antiderivative at 4, and then you find those values. Alright, so first I plug 4 in. So it's going to be 4 times 4, which is 16, minus e raised to the 8 divided by 2, minus 0, so that zeroes out, e raised to the 0 divided by 2. Alright, so that's 1/2, 16, so I'm going to write 16 minus 1/2 minus e to the 8 over 2, which comes out 33 over 2 minus 1/2 e to the 8, which is approximately negative 147. Ooh, this is a big negative number. So I'm going to assume that most of this area, if not all of it, is below the x-axis. Negative 1473.98. Alright, so that's exactly what that integral equals, and that's it. So I'm going to graph this. I'm actually going to pop up my graphing calculator and put it there, and so that we can see it. So 4x, not 4x, 4 minus e to the 2x minus. Sometimes this does not like to work as well. Alright, let's try it again. 4 minus e to the 2x Alright, I'm going to leave a standard window. We'll see. Graph. Alright, so there's the graph of the function. So crosses right before 1 and then goes down. So if I go back and graph it on my picture here. Alright. So again, it crosses here at 0, 4. Right before 1 it crosses. So it comes down, but then it decreases really fast. Shooting way down really fast, right? Because it's exponentially moving down, so it's shooting way down. And so we're going from 0 to 4, and so 4 would be way off my page here. So if I were to shade this in, there's a little bit of positive area here, but there's a whole lot of negative area that actually goes way off my picture there, and it should make sense because that's what my answer got. So the graph is sort of, does my answer make sense? Yes. There was a little bit of positive, but there was a lot more negative, right? Most of the areas, so there's way more negative area than positive area, right? The difference was way bigger down here, and the picture reflects that. All right, we'll stop there. I'm going to pick up the next 2 examples in the next video.